Second buffer style example is making a buffer from a weak acid in excess and mixing that with a strong base, which is a limiting reagent. So all of this will get used up. In the process of mixing these together, we'll see neutralization and a salt formed, so lots of salt formed, and in this case we'll have quite a bit of a weak acid left over. It's asking you to work out the pH, and we're told that the Ka is this value here, so we'll jump straight in with the Henderson-Hasselbalch. So what you need to do is to work out the concentrations of the salt produced and the weak acid that's left over. So the first thing to do is to work out the number of moles using MV/1000 for HA, which is 1 times 25/1000, which is 0.025 moles. Next thing is work out the number of moles of OH minus, and that again is MV/1000, and this time it's 0.64 times by 25/1000. Please note at this point here that this value here is different to the one in the booklet. The one in the booklet is incorrect. This is the correct value to use. Calculate the number of moles of OH. Now this should be limiting, so it should be less than this, and it is, and it's 0.016 moles of OH. So the next job is to work out how much weak acid gets used up and how much salt is produced. So the reaction is going to be weak acid reacting with strong base to produce salt and water. We're going to start off with 0.025 moles of this, 0.016 moles of this, none of this and none of this. After the reaction, this will go down by 0.016, this will go down by 0.016, this will go up by 0.016, and this will also go up by 0.016. So what we end up with is a weak acid number of moles equal to 0.09. We don't have any of this at all, and we have produced 0.016 moles of salt. We're not interested in how much water we've got. So these are our mole values. The next step, we have to convert the number of moles of each of these into a concentration value, because that's what the Henderson-Hasselbalch equation requires. So to do that, we do 0.09 divided by the volume that we've made, which is 50, and then times the whole thing by 1000, and we get a concentration of 0.18 moles per decimeter cubed. Do exactly the same for this one, so it's 0.016 divided by 50 times by 1000, and we get a concentration of 0.32 moles per decimeter cubed. Now, with those two values known, we then go back to our Henderson-Hasselbalch, which is this. We now know all the values that we need, and in this case it's 0.18 over 0.32, and we can work out the H plus concentration to be 9.7875 times 10 to the minus 6. Now note, I'm going to quite a few decimal places here, quite a few sig figs, and the reason for that is because we have to work with a very large amount of accuracy. Once we know the concentration of the H plus, simply plug it into your minus log. Best thing to do is to keep this value in your memory of your calculator and then do the minus log of it, and we get a value of 5.01.